not to give you any restrictions on that. So make it large enough that I can read it, but I don't really care what font you use, how much spacing, and all of that. I think we're hopefully all grown up enough to be able to come up with a reasonable PDF format without me giving you specific instructions there. Okay, while I have the chat window open here, any other questions around this assignment? So 2 pages is not a lot of stuff. So, focus on the things that you find interesting in the timelines of those people. You will not be able to talk about, every bug report and every commit and every code review they've done. Again, if there are particular GitHub users that you think are more interesting than the 2 that I picked there, definitely open to that. Obviously, don't pick somebody who had 1 commit in 2018 and hasn't done anything since. There's not a lot of interesting stuff you can write about those. Also, keep in mind that some GitHub contributors might be very active, but in private repositories, you won't be able to access that data. So for this, it kind of makes sense to pick somebody who's fairly active, who contributes to a lot of public repositories, and maybe somebody who started their open source career on GitHub, because GitHub isn't that old yet. It's going to turn 13 years this year. There might be some open source contributors who actually have transferred to GitHub from somewhere else. I would not pick somebody who has transferred from somewhere else, because then you would need to look at multiple data sources to figure out what they did. The 2 that I picked for you should not have any of those issues. Okay, I don't see any other questions coming, so let's assume there aren't any more. Otherwise, of course, feel free to ask something on the discussion forum. The next little poll question that I had, and that's going to lead into what we'll talk about in the lecture today. Let me just set it up. Let me go back to sharing my screen here. Sorry. Share. There we are. Okay. So today we'll talk about source control management systems in the open source community. And before we start, I just want to get a feel for which systems you might actually be familiar with already. What source code management tools have you used? Only Git, SVN, and Git, CVS, SVN, and Git, none. Something else? None of these. Okay, let's do this quickly. This is the link for voting. I'll try to find my chat window again and post it. Wow, this is fantastic here. Here's the link, and then I'll go back to sharing my screen. And then if you could just fill that in so that I have a quick idea which source control management systems you are familiar with. Okay, thank you for the answers so far. That's 6 answers as of now. Let me refresh it again. Okay, cool. So we have a clear majority for SVN and Git. Excellent. I think that gives me a very clear picture. Most of you are obviously younger than me. I started programming before the days of SVN. Okay, something else, and none of these are pretty rare, so I don't think we need to go into detail on those. Okay, so for the lecture today, that's exactly what I'd like to talk about. Source control management in open source projects, what used to be used in the past, and sort of what's being used now. As you can tell, a lot of the lecture and also the material and the pracs focuses on GitHub. So I'm assuming from that you get the idea that these days Git or GitHub are pretty common. Let me open this in Acrobat though, just a second. And we'll go back to sharing. Okay. So these days, open source, a lot of it uses Git. A lot of it is hosted on GitHub, but not. I guess that there are sort of some limitations both ways. Not everything that's on GitHub is open source. We talked about that briefly last week, that in order to be open source, something needs to have a license. And also not everything that's open source is necessarily hosted on GitHub, and especially historically, a lot of things used to be on very different platforms. And that's what we'll talk about for the lecture today. Okay, so very early approaches to open source, it was basically just a small group of people getting together, deciding that they wanted to develop a piece of software together, and a lot of these, a lot of the coordination, collaboration during that time happened by email. With very simple tools such as diff tools, which you will still find, in the Unix command line, for example. And actually, historically, a lot of open source projects were sort of favoring Unix and Linux as a platform, mostly probably because Unix and Linux are open source projects themselves. And that's actually remained true because Git, of course, was developed by the same person, Linus Torvalds, who developed Linux. So the first version of Git and the first version of Linux have the same developer. So I think there's still sort of this connection between Linux and Unix and the open source community. Thanks to GitHub in particular, I would say that these days you can participate in and contribute to open source very easily from any other operating system. That did not always used to be the case. So back in the day, it was command line tools such as diff, which would show you what actually changed between two versions of a file. Patch, which is a Unix command line command again, that can take a diff and actually apply it to a particular file. The tar format, which is an alternative to zip, was very popular in the open source community as well, because developers had to exchange these large sets of files with each other with the latest version. And this exchange was usually done by email, and each developer would sort of contain their own, would maintain their own local version of a particular open source project, such as the Linux kernel, and then they would send patches to each other by email, which, as you can probably tell, has quite a few issues, because if you're only receiving patches by email, then you have to make sure you stay on top of your email, because otherwise your local copy of the open source project that you were trying to contribute to will never be up to date. It'll always be like this old version that may have some patches applied to it, but not others. So that's how it started, and I think we're talking 60s or 70s here. Right, patches, basic tool of code exchange, several formats available. They contain a short context for each change, and there are sort of different tools for it. But I think that's actually better to explain if we look at an example. Of course, this link is not clickable at the moment. Just a second, let me open the link. So I think this is actually the what's happening here. Copy too much. Wow, this is very successful here. There we are. No, yes. What's happening? Come on. Okay, it doesn't want to open that link at the moment. What's in there? There's a dash missing. EA PowerPoint to PDF conversion. What's happening now? There's another dash there. This is fascinating. There we are. I've already zoomed in even. Okay. So this is what patches looked like, what is this, 17 years ago. It's basically a huge mailing list thread that people are using to exchange patches. So now that I've scrolled through, you have a bit of an idea of how big this really is. Let's look just at the first one here, for example. So this, as you can tell from the email header, is supposed to be a patch, yeah, to fix the declaration and bean info constants. So we seem to be talking about Java here. So the email patch that was sent would have a short description of what the patch is supposed to do. So these constants are now supposed to match the documentation. And then you see what has actually changed. So in this case, the syntax means that, at line 74, something new has been added. Well, the pluses are for added, the minuses are for deleted. The deletions apparently already happened in the previous year, 2003. The additions happened in 2004. And then you see this little method here where you can see some lines that were removed. So this one has been removed and this one has been added thanks to the pluses and minuses in the front. GitHub in the web interface still uses a somewhat similar annotation, but much nicer represented graphically with green and red to visualize additions and deletions respectively. And also GitHub interface now makes it much easier to comment on changes like this. And you'll probably talk about this in the pracs as well. So this would have been the original message. I want to fix the declaration of these constants to match the documentation. These are the 4 lines that I've changed. And then sort of as a replacement, or not a replacement, as an early version of code review, then people respond to this email thread saying, in this case, these shouldn't be needed. Our coding standard is to omit redundant modifiers. So in this case, they didn't mind the change overall, but they didn't like these particular modifiers. All of this, as you can tell, sent by email back and forth from this guy at Red Hat to this guy at optonline.net. So, this might look manageable if you just look at one of those emails with one of those changes, but that's the reason I picked this particular website. These are all the email threads in the time window of 3 months, 17 years ago. And, we have lots and lots and lots of these messages. And as you can see, in some cases, the reply is a lot more complex than in the small example we saw. Let's click on a random one here. So here somebody is trying to fix a bug. Which lines did they add or delete? Did they actually change any lines? Maybe not. Then people are responding to it. Even inline responses. So somebody's saying it's interesting. You scroll further down, you have another response, and so on. You can see that easily that things like this would get out of hand, and there obviously wasn't interest back in those days to use version control to not have to rely on sending emails back and forth like this. Okay, that's really all I want to say about this example. This is what version control in open source looked like, and 2004 isn't even that long ago. A lot of big software projects have been released long time before 2004. Windows, for example, came out in the early 90s, so more than a decade before the open source community was still relying on really long email threads to do version control. There were quite a few rules that you needed to follow in order to send patches to these sorts of mailing lists. So you always needed to include your diff. You always also needed to include your diff stat, which basically just says how many lines you added and how many you deleted. You needed to include an explanation why are we doing this patch, so a bit of a rationale documentation. Um, Encoding obviously had to be plain text. People did not want to see funky pictures or animations in these sorts of emails. They just wanted to see the pure source code. All of these are things that version control systems or hosting sites these days take care for us. You would never think that you have to make sure that the code that you push onto GitHub, that you have to make sure it's represented as code and not color coded in HTML. So I guess our tooling has made quite a bit of progress since then. Similar to what I'm hoping we're still teaching our software engineering students is, break up patches into logical boundaries. Don't try to submit one patch that solves 5 problems at the same time. Ideally, then you want to submit 5 patches so that people can decide which part of the patch they want in their project and which one they don't. Follow the coding style, make sure you're sending it to the right place. Be patient if people don't respond right away. A lot of this is still true with modern code review as well. And for some projects, there was actually this idea that somebody else needed to sign off on a patch in order for it to go into the system, in particular in more strict projects such as Linux, or at least for a long time, the person who wrote the first version of Linux, Linus Torvalds, would not include anything into the official version of Linux that he had not personally vetted and signed off on. Okay, those were the mailing list days of open source, probably until sort of the mid 2000s. And then after that, or even in parallel to that, the first source code management systems were used by open source projects. The old ones, and I have to admit I can't even remember what these abbreviations, the acronyms stand for. Revision control system, I would guess, but I'm not 100% sure. Feel free to look this up if you're interested in the history of open source. But the first generation of these systems would manage files individually, so they wouldn't even figure out that there might be dependencies between different files, and they weren't really designed for collaboration yet. They were designed to be basically a backup on your own machine, and they had serious limitations, such as only one person editing a file at a time, which, as you can imagine, is impossible to do in large open source projects or large any software projects. And it's the kind of limitation that ultimately has given rise to technology such as Google Docs now, where we can all edit the same thing at the same time. Early source control management systems did not have any functionality for merging, but they did provide some history, and they did allow that you could sort of trace each line back to who added it, who modified it, and when did that happen. And that's something that's still true on GitHub, right? If you look at a GitHub, any GitHub projects really, and you find a particular line of source code in there, you'll always be able to go back to see, where did this line come from, who has changed it in the meantime, in many cases, who has reviewed it, who's basically responsible for this line to be in the code now. So sort of this traceability is something that the open source community has put importance on from the beginning. Then after that, the first version control system I would say that was really big was CVS, Concurrent Version System, which was the first big one that allowed for parallel development, so multiple people working on the same thing at the same time, and that had, today we would say, relatively rudimentary support for conflict resolution. If two people were editing the same line at the same time, same thing as today, with Git and GitHub, there is a conflict there if multiple people change the same thing at the same time. How this kind of merge and conflict resolution is done has improved a lot over the last few years. So it used to be that if two people change the same file at the same time, the whole file would just be one big conflict. Then it got a bit better that, maybe it was areas of 5 lines of code that, if I was making changes at the beginnings of the file, somebody else was making changes at the end of the file, it could handle that without requiring manual conflict resolution. And now it's getting better and better, and we almost have semantic conflict resolution in place now, where systems can automatically tell whether two conflicting changes are actually conflicting, or whether we just added a different additional functionality in the same place. But the point was that CVS was probably the first big version control system that actually had some of this kind of conflict resolution. It's dominated open source, free open source software development for more than 10 years, sort of around the new millennium. And there are still some projects that swear by it. But as you also filled in the survey, a lot of us have moved on since then. Some of the limitations of CVS are that it wouldn't detect rename. So if you rename a file, it would consider this as, you deleted an entire file and then you added an entire new file to your repository, which can make it really difficult to trace back when and why something happened, right? You would rename a file and you would basically lose your entire fine-grained history, because you couldn't really go past that huge change anymore. That basically something that CVS thought was a huge change, because you deleted a bunch of files and you added a bunch of new files. In reality, all that happened was you renamed a file or a few files. CVS relies on a centralized server, so you would have one server in your development team in your company where all the source code is, and merging. There was some support for merging, but it wasn't very good yet. Some of the limitations of CVS then gave rise to this discussion where does it make more sense to have centralized version control or distributed version control? As you probably know, Git is distributed, and it has sort of become the standard now that we're using distributed version control system. We'll talk in a few minutes about why that is. So CVS was still very much centralized. It required a central server. Every developer had to check out from that central server, make their own changes, and then move their code back to the central server. So with CVS, you always knew which physical machine had the official copy of your project. Quite different to GitHub now, right? Where we don't even know where GitHub stores this stuff, and as soon as we fork something, we have our own version. We clone it, and we have an official version on our own machine. Distributed version control systems exactly try to address some of these limitations, make the entire project history available to all developers, don't just store it on that central server, and make branching and merging a lot easier. The next big one, and many of you seem to be familiar with it, which is good. The next one was then Subversion, or SVN. Often described as CVS done right. So learned a lot from what went wrong in CVS, or what was not ideal in CVS, and sort of handled it a bit better. So handled renaming better, had better branch support, project-wide revisions, things like that. But it's still centralized. Unlike Git, it's still a centralized source control system. Even with an SVN repository, you still knew exactly where that repository was. I think something that's not mentioned on the slide, I think SVN then also added easier to use user interfaces. So SVN was probably the first one that had some not command line clients that were easy to use. I think CVS was still very much based on, if you weren't able to use the command line, then there was no way you could figure out how to use CVS. Whereas with SVN, there were Subversion. There were some tools available that made using it a bit easier. Right. So Subversion still centralized. And that gets us into distributed version control systems then. There were some early systems as early as last century. None of them have really taken off, so at least when I first heard of them, it was not something I was familiar with. Um, and chances are you have never heard of these names either. So point is, there were some early systems that explored the idea of distributed systems, but at that time they didn't really take off. BitKeeper, that is one that you may have heard of, was probably the first distributed version control system that actually had a bit of a user base, in particular because the Linux kernel moved to using that one in 2002. Quite difficult to use, and has definitely been superseded by Git since then, but it was sort of the first big distributed system. Okay, there are a bunch of other systems that then have started about, what is this, from 18 years ago. Bazaar, Darks, Mercurial, Git, and Monotone. There's a good chance the only one that we've heard of is Git. I think Mercurial is probably the next popular one. But they all essentially implement similar ideas, and it might be one of those cases where Git isn't necessarily better than the other four on that list here, but because Git has been developed by the same person who developed the Linux kernel, maybe it had a bit more of a momentum from the beginning. Right, so at that time there was a bit of a decision whether big projects such as the Linux kernel should use BitKeeper or move to Git. They ended up moving to Git, and that actually happened in 2005. I don't think we need to go into details on this. Okay, I think I mentioned some of this already, that at least traditionally source code management systems for software in general, but open source in particular, have definitely been dominated by command line. And even today, to get the most powerful use out of Git, you need to use the command line. There's no way to do everything through any of the graphical clients, even the official ones. So the command line definitely dominates this kind of thing. And command line, of course, is generally the best choice if you want to do something really quickly, right? Because you're not wasting computing resources on making something look pretty, but you're just telling the computer, telling the version control system what to do in as simple a way as possible. There has been a push now towards more web interfaces. You will have seen some of those, in particular the ones that are sort of integrated into GitHub now. And I guess another recent development that was definitely pushed more by GitHub is to not think of version control in isolation, but to integrate it with other tools that developers are using, in particular bug tracking systems, right? Often when you make a commit to a big project, it's related to fixing a bug that has been reported in a bug tracking system somewhere. Historically, these just used to be completely disconnected systems, right? You would have their bug tracking system running on one server and your version control system on a completely different server. They wouldn't know each other or have any idea how to talk to each other. Obviously, platforms such as GitHub now, bring all of this together and make it really easy to link bug reports to commits and vice versa, and do some of this even automatically under the hood. Okay, that gets us into Git. Gonna spend a few more minutes talking about this. I think the pracs this week will cover Git in a lot more depth, and Git is also not the kind of material that's really really good for lecturing about. It's really something that you just need to sit down with your command line or your web interface and actually try these different things to really figure out how they work. I'm sure you have all used Git for other university courses already. I think what the Prax this week will be an opportunity to do is to push the envelope on that, to try some of the features, some of the commands that you have never used before. And especially if you are familiar, if you think you're familiar with sort of the basics of Git already, I would definitely encourage you to use the Prax this week to, on purpose create conflicts, try to merge them, try to resolve the conflicts, see exactly what happens in all of those corner cases, have 3 people edit the same line at the same time and all push to another repository at the same time, try to see what happens, how can you resolve these sorts of conflicts. The reason I'm pushing this a little bit is that I want to make sure we're all really familiar with Git and with GitHub before we make contributions to open source systems or open source software projects, because at least in my experience, open source software projects are not very receptive to people who they perceive as not having understood the basics yet. So I want to use the Prax in particular in this course. Of course, Prax we only have in the first 5 weeks, to make sure we're all up to speed on Git and GitHub. Okay, so make sure you're familiar with all of these terms. Hopefully, a lot of them are familiar to you already. Commit, push, pull, and especially push and pull is something that has only really become popular with Git. Commit message, you will all have written several. Repository, clone, checkout, working copy, revision. Diff, tag, snapshot, that's another thing you might want to play with. Branching, merging, conflicts, revert, lock, and pull request. I would actually say it would be good if we're all familiar with all of these. I posted the slides on my uni, obviously, so feel free to go through the remaining slides. We won't cover all of them today. Feel free to go through the remaining slides and just make sure that you are familiar with these definitions, or at least that they make sense to you. So maybe I'll take a quick break there just to see if there are any questions. I don't see anything in the chat at the moment. That's good. Okay, no questions as of now. Then I will use the last 5 minutes to briefly walk you through some of the core concepts of Git, assuming that this is hopefully not the first time you hear about these. If it is, or if you're really worried about your background in Git and GitHub, definitely go to the Prax this week. And there's lots of good web resources as well to get up to speed on these things. If you need any pointers, definitely reach out to me. So, what is a commit? A commit is basically making a change to a project to store a change in the version control database in such a way that it can be incorporated into future releases of the project. Something that's a bit interesting, I guess, is that a commit can be used as a verb or a noun. So you can have a commit, or you can commit something. You're likely familiar with this. But I think something that has changed, so I will go over this a little bit, especially because most of you were familiar with SVN and Git. So something that has changed is that Git, or decentralized distributed version control systems in general, often require you to do things in 2 steps, to do a commit and then a push. Some in centralized systems such as Subversion or CVS, a commit and a push were basically the same thing. In distributed systems, commit and push are different things. So a push is to publish a commit to a publicly available online repository from which other users can incorporate it into their copy of the source code. So a commit is something that happens on your own machine and makes sure that you have this unit of changes that you want to incorporate into your local version, that you could roll back, that you could do all sorts of things to. But a commit in the language of distributed version control systems does not make your code available to anybody else at this point yet. You need to push it to somebody else in order for it to become available to others. Because version control systems such as SVN and Git didn't have that distinction, there you will encounter there's still quite a few people in the open source community or software engineering in general, I guess, that sort of confuse the terms and will say commit when they actually mean push. So that's just something to watch out for. A pull is then sort of the opposite operation to a push, to pull somebody else's changes into your copy. And again, historically, there has been the word update instead of pull, where update sort of implies that you update your local copy against the official copy. Now in distributed version control systems, we don't really have that official copy anymore, so update makes less sense, and instead it makes sense to pull something. Okay, commit message is obviously the message that you write to accompany a commit, and a good commit message explains the change. Repository is a database where changes are stored. In centralized version control systems, again, we have an interesting difference here. In sort of SVN, CVS, and that world, there is one repository. In decentralized systems, everybody has their own repository. So that's maybe one of the biggest differences that you want to wrap your head around if you want to understand the difference between centralized and distributed version control systems. So centralized systems, one repository. Decentralized systems, everybody gets a repository. Cloning is something that you couldn't do in centralized version control, because it means to make a copy of the repository into your own repository, creating your own repository by copying the central one. In centralized versions, there was only one repository, so cloning didn't work. This is yet another one of those, so checkout is yet another one of those that used to have a different meaning and is now still used in its old meaning sometimes, which can be a bit confusing. So officially, in decentralized versions, checkout just means to obtain the working files from your local repository, which means there's no network involved. It all happens on your machine. So checkout locally just means checkout in decentralized systems only happens locally, and it just means that you pull a working copy out of your local repository. It's something that you usually don't have to do unless you want to go back a few versions and check out a past version from your own local repository. Historically, checkout was used to obtain something from the central repository, which is what we now do with a clone. Okay, working copy is what you're working on at that moment, so the kind of files that you have open in your IDE. I don't think we'll be able to get much further through these slides. But again, what I said at the beginning of this particular part of the slide deck, chances are this has been covered in another course already. If it hasn't, if you're uncomfortable with some of these terms or unfamiliar with them, definitely take a look through the slides. They have what I would consider pretty good definitions of the different operations, and we will be using these in particular as part of the team project. Okay, I think I'll wrap it up at this point. Let me just take another look at the chat window, which for some reason doesn't open by default. Okay, I don't see any other questions. So assignment 1 has been posted. Let me know if you have any questions about that. Details on the group project will be posted very soon. The first thing will be you selecting which other team members you want to work with. And the recording of this will be available soon on Echo 360. So thanks everyone. If you have questions, feel free to get in touch with me via the forum or email, and otherwise I'll see you again on Monday. All right, thanks everyone. Bye.